Hello student, once again welcome to my YouTube channel. In today's video I will tell you about conductance of a metallic conductor and conductance of an electrolytic conductor. Why the conductance of a metallic conductor decreases with increase in temperature, whereas the conductance of an electrolytic conductor increases with increase in temperature. So to know why it decreases and why it increases in case of electrolytic conductor, in case of metallic conductor, please watch the video till the end. And if you get benefited from this video, please like the video, share the video with your friend, and do subscribe my channel. Let's start with our topic, conductance. Now before going into conductance, we should know what is meant by conductor. What is meant by conductor? Conductor are substances which allow electricity to pass through them. Conductors are substances which allow electricity to pass through them. And we have two types of conductor. One is called metallic conductor, another is called electrolytic conductor. One is called metallic conductor, another is called electrolytic conductor. Now we should know the basic difference of metallic conductor and electrolytic conductor. I will tell the difference. You will write down in your notebook because I will not write, otherwise the video becomes too large for you to watch. So first point, in metallic conductor, metallic substance which allow electricity to pass through them but does not undergo any chemical change. Metallic substance which allow electricity to pass through them but does not undergo any chemical change are called metallic conductor. Whereas electrolytic conductor, those substances which allow electricity to pass through them either in their molten state or in the form of their aqueous solution and itself undergo chemical decomposition. Those substances which allow electricity to pass through them either in their molten state or in the form of their aqueous solution and itself undergo chemical decomposition. So for example, sodium chloride. Sodium chloride solid, it does not allow electricity to pass through them, but in the molten state, molten or aqueous medium, it allows electricity to pass through them due to formation of sodium ion and chloride ion. So by now you all can guess that in case of electrolytic conductor, the ions are the charge carrier, whereas in metallic conductor it is the electrons which are the charge carrier. In case of metallic conductor, electrons are the charge carrier, whereas in electrolytic conductor it is the ions which are the charge carrier. So in the second point we will write here electrons are charge carrier, here we will write ions are charge carrier. The third point, now electrons has negligible mass, so whenever an electron is transferred, no mass is transferred. So here we will write no mass transfer takes place. In here, third point, right. Suppose you have added sodium chloride in water. So whenever sodium chloride is dissolved in water, it will produce sodium ion and chloride ion. So this sodium ion and chloride ion, the moment you dip two electrodes in that solution and you pass electricity, what will happen? The sodium ion, it is the cation, it will move towards cathode. The negative ion, Cl minus ion, which is called anion, will move towards anode, and during its movement it is transferring mass because sodium ion has some mass, chloride ion also has some mass. So in case of electrolytic conductor, mass transfer takes place. Now come to the fourth point. The fourth point, which is the most important point. Fourth point here, it is conductance. Conductance decreases with increase in temperature. Conductance decreases with increase in temperature. Here conductance increases with increase in temperature. So this we have to know why conductance decreases in case of metallic conductor with rise in temperature and why conductance increases in case of electrolytic conductor with rise in temperature. In case of metallic conductor, conductance decreases with increase in temperature. In case of electrolytic conductor, conductance increases with increase in temperature. Now why this happen? Now to know why this happen, you need to know the metallic bonding. Now many of you know that metallic bonding, there are so many statements of metallic bonding. Here we will discuss only one model, that is electron C model. Electron C model. Now according to this electron C model, what happened? The metal loses its valence electron to form metal N plus N number of electron. According to this model, the metal loses its valence electron, these are the valence electron, and it forms metal N plus. Now this metal N plus is called core or kernel, Kernel, kernel. Now this electron, they form a electron C, okay, they form electron C, and the metal ion Mn plus, it get immersed in the electron C. Now the moment it get immersed in the electron C, there will be attraction between the electron and the metal ion, like this, from all direction. There will be attraction here, from all direction there will be attraction. So we define the metallic bond as the non-directional forces of attraction between the metal ion and the electron in the electron C. Once again, the non-directional forces of attraction between the metal ion and the electron in the electron C is called metallic bond. Now that is what about metallic bond. Now in this model, from this model we can explain why the conductance decreases upon rise in temperature. The moment you are increasing the temperature, what happens? The metal ion start vibrating above and below. So the metal ion is vibrating. If the metal ion start vibrating, then what will happen? Suppose you have put a potential difference on either end of the two end of the metallic conductor. So because of this potential difference, the electron will start moving either from left to right or from right to left. The moment you rise the temperature, the metal ion will start vibrating more and more. If it vibrates more, the flow of electron will be obstructed to some extent. So more is the temperature, means higher the temperature, higher is the vibration and higher is the restriction in the flow of electron. So with rise in temperature, conductance increases. This is due to vibration of the core or kernel of the metal. Hope you understand all these things. Next we will move on to the electrolytic conductor. In case of electrolytic conductor, we have to consider so many things. So many things means, suppose you have sodium chloride. So the moment you dissolve sodium chloride, you are having sodium ion and chloride ion. Okay. Now this sodium ion and chloride ion, there is attraction force. Now if the attraction between the cation and the anion is very strong, then the cation will not move towards cathode, or it will show difficulty in its movement towards cathode, and the anion will move slowly towards anode. So stronger the, this is the first point, stronger the ion-ion attraction, weaker is the ionic mobility. So stronger the inter-ionic attraction, weaker but lower is the ionic mobility. Ionic mobility. If the ionic mobility is low, then conductance will be low. The second point, the ion solvent interaction. The moment you are adding sodium in water, what will happen? The sodium chloride in water, the sodium ion will be surrounded by water molecule like this, because water is polar and the negative part of the negative end of the polar water molecule will orient towards the sodium ion. This is called solvation of the sodium ion. So if the ion gets solvated, then it has to move with the solvent molecule towards the cathode. In case of chloride ion, it has to move towards the anode with the solvent molecule. So more the solvation, more the number of solvent molecule around the sodium ion, more difficult it will be for sodium ion to move. So higher the solvation of the ion, lower is the ionic mobility. So the second point is, higher the solvation of the ion, lower is the ionic mobility. So lower the ionic mobility, lower is the conductance, because in case of electrolytic conductor, it is the movement of the ion which is responsible for the conductance value. For metallic conductor, it is the movement of the electron which is responsible for the conductance value of metal. So the second point is ion solvent interaction. Now we will move on to the third point. The third point is very simple. It is solvent-solvent interaction. What is solvent-solvent interaction? Suppose you have ethanol. Ethanol, it is having one OH group. Ethanol is having only one OH group. Suppose you have ethane 1,2-diol. So it is having two OH group. In case of ethanol, the forces of attraction is hydrogen bonding, we all know. In case of ethane 1,2-diol, again the forces of attraction is hydrogen bonding, but this time there is two hydrogen bonding because there are two OH group. Now if you take propane 1,2,3-triol, it has three OH group, so it can form three hydrogen bond. So if it has been three OH group, it will form three hydrogen bond. So the solvent-solvent attraction is maximum in case of propane 1,2,3-triol, then ethane 1,2-diol, then ethanol. And we know propane 1,2,3-triol, we call it glycerol, and we all know glycerol is very much viscous as compared to ethanol. So higher the solvent-solvent interaction, higher is the viscosity of the solvent, and if higher the viscosity, lower is the movement of the ion through the solvent. Once again, higher the solvent-solvent interaction or attraction, higher is the viscosity of the solvent, and higher the viscosity, lower will be ionic mobility and lower will be the conductance value. And as you increase temperature, what will happen? Now as I told you that with rise in temperature, conductance increases. Why with rise in temperature conductance increases? Because with rise in temperature, the kinetic energy of sodium ion, kinetic energy of chloride ion, all the ions, the kinetic energy increases. Now if kinetic energy increases, the mobility of the ion increases, mobility increases, conductance increases. Second, the solvent-solvent attraction. We all know with rise in temperature, the viscosity of the solvent decreases because the hydrogen bond start breaking with rise in temperature. More and more the number of hydrogen bonds start breaking, the viscosity of the solvent decreases. As the viscosity decreases, the ionic mobility increases. So once again, with rise in temperature, the mobility increases, conductance increases. So conductance of electrolytic solution increases with rise in temperature. Hope all of you understood this. If you like this video, please do share it with your friend, and please subscribe my channel so that you get notified whenever a new video comes.